Thank you very much for connecting this morning, this afternoon, or evening, depending on where you are. And welcome to our webinar Is My Facility Compliant with Combustible Dust Hazards? Thank you very much for coming. We know that you all are very busy people, but you took the time to connect today, and we will make it worth it. So stay tuned. I'm Andy Biancotti. I'm the moderator this afternoon, and we want to make this very practical for you. You will leave this webinar with very actionable information this afternoon. So thank you very much for connecting. A few announcements before we start. This webinar is going to be interactive, so many of the questions that it will come up, maybe you submitted a question in your registration form. That's great. We'll analyze that in the Q&A section at the end of the webinar. But if you, as we cover the information, if something comes up to your mind and you want to ask a question, you can write it in the chat box, and then we'll be able to analyze it at the end of the webinar. Also, we'll send you a recording of the webinar after the webinar ends. So if you want to review some of the information that we cover, you will have that as well. And if at this point you want to invite a team member, a colleague, or anyone that you think will benefit from this information, I'm just pasting here the link in the meeting chat so that you can copy and forward that to your friend or colleague, and they can connect to this meeting. So thank you very much for doing that. We also, all of us speak Spanish, so if you have any question in Spanish, or maybe you want to talk with us after the webinar, feel free to call us. If you know any of the information maybe is not as clear in English, we can clarify that for you. All right, so what are we going to cover today in this webinar? The subjects first, why learning about combustible dust is important, what is combustible dust, and how to know if my dust in my facility is combustible. Then we're going to have our special guest from Boss Products, Joe Castigar, explain the fire prevention technologies, the explosion protection technologies, and also some industry-specific applications that they have experience with. And at the end, the questions and answers sections with your questions. We look forward to that part as well. That part is optional, so if you only have time for the first hour, that's great. If you want to stay a little longer, that would be amazing as well. All right, so without further ado, let's give our attention to Matt Coughlin with the first part of the webinar. Is this actually important?
All right, there we go. Thanks, Andy. So yeah, why is this important? So we often get questions from customers, do I actually need combustible dust safety equipment? What are the requirements? Why bother dealing with all this? So of course, on the one hand, you have regulatory requirements, right? So oftentimes customers will be told by their insurance company, the local fire marshal, the permitting agency that you're dealing
Actually
with,
important?
or something along those lines that they have combustible dust or they might have, so they need to get it done or face some regulatory penalties. So that's important, of course. But what's more important is the actual risk from combustible dust itself. So there's a couple of statistics mentioned there. 3,500 dust explosions in the US over the last few decades. That's not good. Major incidents with deaths and injuries. So, your EH&S people out there, not to mention management in general, are certainly, should certainly be concerned about combustible dust if it's present in your facility. So you want to keep your people, your products, your equipment, your facility safe. Combustible dust is a risk that needs to be managed. So I think on the next slide, Andy has some attention-grabbing videos to kind of give an idea what can happen in your facility with these kind of risks don't get managed. So ammonium nitrate, not dust per se, but definitely crazy video there. Coal dust we encounter, if you're dealing with coal, it's extremely combustible. Wood dust facilities, we deal with these all the time. People think, it's just sawdust. It may smolder, but it's not going to explode. There you go. That's a pretty big fireball there. And of course, we've got a refinery here. Let's see that one. Yeah, you see the fire down there. All right. Anyway, so, whoa, there we go. Big explosion. So obviously, that's the last thing anyone wants to see at their facility. So, I think you're here because you want to understand what the risks are and how you manage them. So let's start with the basics. So what is combustible dust? The definition, basically any solid material that has been ground down or reduced into particle sizes that are small enough that they can catch on fire. And so it's not just the material, it's the characteristics of the dust you're producing in your facility. So you may have aluminum in your facility, but if you're not grinding, machining, etc., creating fine particles out of it, it may not be combustible. On the other hand, you may have, something that's not highly explosible generally, but if you're doing a lot of sanding of wood and so forth, you may be creating very small particle sizes and the concentrations that will allow that under certain conditions to catch on fire and explode. So that's basically the idea for what is combustible dust. Next slide, Andy. So very common combustible dust we see. There's a whole gamut of them, but food processing, and if you're a food processor or you're processing, creating a food product, you're probably aware that any kind of carbohydrate is highly combustible. So sugars, flours, starches, if you're processing almonds and pistachios, nut dust, that kind of things, definitely in the combustible dust category. Grains, you may have seen some videos of grain silos when combustible dust catches fire. It can be pretty explosive. So wheat and barley and that. Metals can be extremely explosive. Aluminum, titanium in particular, extremely combustible under the right conditions. Wood, if you have a wood shop, your a crate shop or something like that, there are specific NFPA requirements that are geared towards wood shops because sawdust and paper dust and so forth is also combustible. Plastics can be combustible. Chemicals, of course, coal and other carbon type based materials can be highly combustible, and on and on and on. So if you're not really sure the facility that you're working at, if you're not sure if the dust they have is combustible, well, there's a process to follow to figure that out. Next slide, please. So really, what are the risk factors here? So there's kind of two risks we're talking about. On one hand is fire risk. On the other hand is explosion risk. So to start a fire, what you really need is three components. You need a fuel, so a combustible dust in our case here. You need oxygen that could be provided by airflow through a ductwork, mixing with your dust or settling with your dust. And you need an ignition source. So that could be a spark generated by a grinding process. It could be some kind of an open flame if you're cutting or welding. It could be a spark generated by a material handling fan. So anything could generate a spark combined with oxygen and fuel, you get a fire. For an explosion, there's a five-sided pentagon, which kind of describes. So you have your same three, you have your fuel, oxygen, and your ignition source. But for an explosion, you also need disbursement. So you need your dust not to be settled in a pile, but dispersed throughout the air. And then you need confinement. So if it catches on fire, if it's not confined, you may have a fireball, but you will not have an explosion. But once you enclose it in a bag house or a ductwork or a silo, now you have all five risk factors for an explosion. So those are the kind of, as we get into Joe's part, we're going to talk about fire protection and explosion protection. But really the factors that go into those are the three for fire and the five for explosion, which include the confinement and disbursement. Next slide. So is my dust combustible? So how do you know? So generally speaking, or in almost every case, step one of the process is to do what's called a DHA, which is a dust hazard analysis. So if your facility is handling combustible dust, or you think it might be, the requirements, OSHA requirements, and NFPA and so forth will direct you to take a sample of your dust and send it out to start your DHA. And essentially, the first step of that is the lab test, where they'll take about a 3 to 5 pound sack of your dust and they'll run it through some processes to determine how its size, so the particle size and density, the typical moisture content, and other variables. And they will come up with either a go, no go, like it doesn't meet the combustible dust requirement, you're good to go. Go ahead and proceed with your business. Or it's a go, it is combustible. And if it is, then that DHA report will also categorize your dust and give you some important measurements, which include the KST or deflagration index, basically how combustible is it. Usually it will categorize it as like an ST1, ST2. There's various categories, which will then direct you to figure out what to do to mitigate the risk from your particular dust. The Pmax is also an important one, which tells you, the maximum explosion severity if the dust were to explode in an enclosed vessel, and that will help you determine how to size your explosion vents and other things like that. But the important takeaway from this slide is if you're not sure or you think you have combustible dust, you must, to comply with your requirements from OSHA and other requirements, is to go get a DHA lab test done. They'll send you back a report and they'll tell you if it's combustible, how combustible, and they'll give you all of those important values to determine, what are the next steps of your process. Next slide, please. So now I'm going to hand it off to Joe Castigar from Boss Products. Baghouse.com has been working with Boss Products for years. They are our go-to supplier and source of expertise for everything combustible dust related. So they make combustible dust safety equipment. They also have a really excellent team who will provide guidance and help ensure that whatever the challenges are at your facility, that you get the right equipment, the right sized safety devices, and that you address all of your compliance requirements. And they do a great job at that. So I'm happy to introduce Joe, and he's going to walk you through some specific equipment types and approaches for your combustible dust. Over to you, Joe.
Thanks, Matt. Next slide, Andy. So when we talk about different types of protection and different types of safety equipment for combustible dust applications, we use what is referred to as the NFPA, which is the National Fire Prevention Association. In that code, in that standard, it talks about different commodities. With the new NFPA 660, it's combined all the different commodities into different chapters. So depending on the type of dust you have, depending on what chapter you follow. So for example, if it's a wood dust application, you would still use NFPA 660, chapter 24, and it points out all the risks, and it points out all the different types of equipment that you would need in association with either fire protection or explosion protection. Next slide, Andy. So these are some of the products and some of the solutions that we can offer as far as layers of protection for combustible dust applications. We offer both prevention, isolation, venting, and suppression systems in accordance with whatever type of industry you may need. Next slide, Andy. So as far as fire prevention technologies, we can do many different things, including if you have return air applications, we can provide abort gates depending on if it calls out for that in the NFPA. If you're returning air back into the building, basically what the abort gate does is it basically shuts off that side of the duct and it prevents fire, smoke, burning material from entering the building. We also offer explosion-proof drums, which basically protect and isolate the bottom of the hopper discharge from the dust collector or the vessel that you're trying to protect. Spark traps, which would be placed inside ductwork, and CO2 fire suppression systems, which we install inside of the collector or vessel that you're protecting. And basically it shoots CO2 and suffocates the fire. Next slide, please. So here's a little video of some of our products and solutions with our spark detection and extinguishing. Different applications that we can work with: pulp, paper, tissue, food, wood, recycling, tobacco. Spark detection is basically where a sensor is installed in the ductwork, and when there is a spark that passes by, it'll send a signal back to a control panel that will tell an output device of some sort, whether it's water extinguishing, a mechanical fire break shutter, an abort gate, to trigger and basically mitigate the potential for a fire. So in this case, they're showing water extinguishing, which is something we can do as well, and provide booster pumps too. We can also do redetect. I've done a lot of applications where sometimes they want to be safer than sorry, and we can do detect, extinguish, redetect, and then possibly put a mechanical fire break shutter as close to the vessel as possible. And basically what happens is it's a knife gate and it triggers and it shuts that duct down. Thermal probes is another additional layer of protection where basically they can either detect at a certain set point temperature or a rise in temperature that can also activate certain equipment as well. And broken bag detectors or dust probes on the clean air side. If you have maybe a bag that's broken or a leak in your filter. And then I talked briefly about the abort gate, but that's what the abort gate looks like. It closes off the duct in the event of a triggering event of a spark, dust probe or thermal probe activation, and it closes off that duct work. We can do different types of controls with this. We can offer different single zone controls up to a 5-zone control panel as well. So we can offer many different inputs, up to 16 different inputs and 10 outputs. Next slide, Andy. So here's sort of a flow chart and basically equipment lined up in a collector application. As you can see at item 1, there's your spark detector. Item 2 would be your water extinguishing. And then as I talked about before, we can do a redetect and a fire break shutter. We also listed down there the NFPA chapters and paragraphs that are associated with these equipment. Next slide, Andy. A little bit more about some of our products as far as what we can offer. The abort gate, the spark trap, and the drum. Next slide, Andy. Our system. So sometimes we have applications where water can't be used for a reason or not, whether it's because the food process can't get wet, or maybe there's no water supply for the end user. We can do a CO2 fire suppression system inside of the vessel you're trying to protect. And in our solutions, we can cover up to about 900 cubic feet of vessel, and they're activated by thermal probes. Next slide, Andy. So the next part of that we just talked about fire prevention technologies. Now we're going to get into explosion protection technologies. So we offer many different types of passive technologies, including explosion isolation valves, venting, diverters, rotary airlocks. And so this is sort of like a chart or a picture of where you would put these pieces of equipment. When it comes to explosions, NFPA calls out for explosion venting and isolating between vessels. So basically, if you have interconnected vessels, you want to provide protection in between each vessel that's connected. Next slide, Andy. This is a video of our explosion isolation valve, the VigiFlap, and how they're tested today.
On the market today, there are several manufacturers of flap valves. Most flap valves are only tested in connection with a single pipeline between the vented vessels and the flap valve. These tests do not include the pipeline on the protected zone of the process. Without including the protected zone pipeline in certification testing, flap valves may not experience the same pressures and conditions during testing as they would in normal use. Test data proves the need for a pipeline on both sides of the flap valve to simulate the conditions according to intended use. Any test that does not include a pipe on the protected side of the flap valve has resulted in a certification and installation of flap valves that can fail.
So how we test our Vigi flaps is we put both sides of the pipe together, because what it's going to explain is there's going to be pressure on both sides when an explosion happens. Basically how it works is the pressure wave is going to close that flap shut and the fireball is not going to be able to pass through to the other side of the duct.
The very high oscillations in the pipeline come from the powerful closing of the flap, which converts dynamic pressure to static pressure and produces shock waves, the oscillations being much smaller in the vessel. In normal use, it is likely that the pressure on the protected side of the flap valve may briefly be higher than the pressure on the unprotected side, due to the high acoustic oscillations on both sides of the flap. So if the locking device is not prepared for a possible reopening, it can lead to a secondary explosion.
There's your pressure wave pushing the flap. This valve wasn't certified in accordance with a secondary pipe with the other side of the pressure, and you get the explosion on the other end. So we offer the Vigi flap, which is our explosion isolation valve. It can be used on both clean and dirty side of the collector or the vessel that you're protecting. Next slide, Andy. This is basically how we can configure our explosion isolation valves, our Vigi flaps. We can put Vigi flaps in a lot of different configurations. It's very versatile when it comes to how you can install them. As you can see, you can put it on the clean side, which would be the left side of that vessel it's protecting. And if you have two inlets, you can put multiple valves. You can have one on one inlet, one on another inlet. You can see that there's elbows in between that. And again, it shows you the pressure closes that flap, and then the fireball comes always after the pressure wave. With the round design, you have minimum pressure drop, so you're not losing your airflow in your process. And you can there's different positions of the flap. It showed a floating position where basically the airflow is keeping that flap open. And then you can also do it in a flap locked open position where it's locked in the open position as well. And you can install it vertically as well. There's a position indicator on these flap valves to let you know if the flap's open or closed. That's that little indication on the side of the valve where you see the green and the red, and then once it shuts, that indication will swing towards the red to let you know that your flap is closed, and there might have been an event, or there may need to be some maintenance with it. These are ATEX certified. Here's a testing video of our Vigi flap. You can see the pressure wave close the valve with that position indicator going into the red, and then the fireball is not able to pass through because the flap is shut. Some other explosion protection equipment we offer. We also have a no return valve, a diverter, and dust sensors and different components that can be installed with your explosion isolation valves with a fully listed UL panel shop. And we can do our own controls. When it comes to explosion venting, we have a variety of different solutions. If you have an indoor application where you need venting on your collector or your vessel, we can offer a flameless vent that goes on top of the explosion vent. And basically, what happens is, in the event of of combustion of deflagration, the vent will open, which will relieve the pressure, and then the fireball will be quenched by the flameless mesh that you see on top of the flameless vent. And basically, on the other side of that flameless vent, all you're going to get is smoke and cloud. We can use these with elevators, dryers, cyclones, filters, whatever type of vessel that you're trying to protect. And we do all the calculations in-house as well. Next slide, Andy. Here's a video of our venting solutions. As you can see, a dust collector without proper venting, storage silos without proper venting, bucket elevators without proper venting. Yeah, Matt had spoke briefly about ignition source, flame, sparks, heat, and friction, and suspended particles, combustible particles, and confinement to get that pentagon. What we can do is, if your collector is also outdoors, we can just put standard vents on there, and we also do offer vent deflectors, which are basically, if you have property or people nearby, you can put this vent deflector panel on the explosion relief panel, and then in the event of the explosion, the vent panel folds over, relieves the pressure, and the fireball shoots up and out, so it doesn't cause any injury to any nearby personnel. We offer different types of explosion vents, flat panels, dome panels. We also offer round panels and high vacuum panels for high vacuum systems. Equipment can be installed indoors. We also have a new flameless low profile vent called the VigiFlam VI, which can be used on bucket elevators and bucket conveyors. It's 50% less volume, and it sits really low profile on your bucket elevators, bucket conveyors to provide explosion venting protection. There's the venting. Those are some flat panels on a elevator. And then some flameless vents. The panel bursts, and then the fireball, like I mentioned before, gets quenched by the layers of stainless steel mesh, and all you get is smoke. Some industry-specific applications. Next slide, Andy. Like I said, we can, depending on what type of application, we can provide solutions for woodworking, food processing, metalworking, the food and agriculture industry, and paper industries. It just depends on what your DHA comes back with and what type of protection you're looking for. And we basically provide suggestions based on what the NFPA calls out in the standard. And I think back to Matt.
Perfect. All right. So We want to make this process as easy on the customer as possible. As you can see, there's a lot of options. You've got venting, you've got isolation, you have quenching, detection, all of this various, options that can apply to different applications. So what do you actually need? This is where we try to help our customers basically put together a plan. So step one in every case is going to be do a DHA, starting with the lab test. Then that's where baghouse.com can help you. Essentially, what we'll do is look at your system and understand, is it indoors and outdoors? Do we need fire protection? Do we need explosion protection? Do we need both? Is spark detection and extinguishing appropriate or not? So this is where it's really incumbent on the facility, the site owner, to bring in someone who understands how to apply OSHA NFP requirements, because there's a whole menu of options. Typically, just as a kind of broad overview, if you have a dust collector and you have combustible dust, at a minimum, you need isolation. So that's on the inlet side of the duct. If you're returning air, you also need isolation on the return air side. You need venting on the vessel itself, and you need some kind of explosion rated airlock or drum. All of these things are kind of standard practice. I mean, we can pretty quickly take a look at your system and figure out, based on your DHA, what's appropriate. So that's where we come in to help put this system together with the support of Boss products. So are we retrofitting? You have an existing system that needs to get up to code. Is it a brand new system? What do we need? That's where we would put together the package and hand it to you as the customer to determine, is this what we want to do? But we're going to be following the NFPA requirements. We're going to basically provide you with a system specification, basically to get you up to code. And then the follow-on is, you have this equipment now. It does require maintenance. There are required inspection and maintenance activities. So that's, again, where we can help educate you as a customer on what exactly do you need to do to make sure for planning and maintaining your equipment so that it's good to go if there is some kind of event in your facility. So I guess the main takeaway that I'd like to leave the customer base with here is that between baghouse.com and Bosch products, we've covered a ton of different applications and industries and situations. We can help you figure out what you need to make your facility compliant and safe. There's a whole menu of options. Bosch products makes a whole bunch of very nice certified NFPA compliant equipment. Between the two of us, as working with you as a customer, we can help you figure out what package is required to keep your facility safe and to keep it maintained, into the future. I think that's the last slide, right, Andy? We have another one here. I'm going to go into QA.
This is the question and answer section. Let me pull up the questions.
Are you going to tee those up for us, Andy?
So the first one is for Joe. It says, in a food industry that handles dust and sugar with some humidity, is a mitigation system necessary? What kind of isolation valve is needed, pneumatic or mechanical?
So again, we had discussed about if you feel that your dust might be combustible, we always recommend doing a DHA. That DHA will point out very specific values. It'll point out recommendations of what type of protection you're going to need. Based on that DHA, we can then go into several different options for protection and mitigation devices. So is mitigation system necessary? It depends on what the DHA comes back with. As far as what kind of isolation valve is needed, it depends. We typically go with a mechanical passive isolation valve in our applications.
Cool, thank you. The next one is how to prevent fire events in laser cutting and laser marking applications when both aluminum and ferrous dust are present.
As far as equipment goes, we can offer spark detection with a mechanical firebreak shutter. And we also do spark traps as well.
Great.
I'll just add too that it is important to go do the DHA, because you may have a mix of dusts that might be extremely explosible, so much so that a regular cartridge collector or baghouse cannot be made safe. You might have to go with a wet collector, or depending on what the DHA says, you might have a mixture that's combustible that we can manage with the spark detection mechanical valves and the like. So it just depends. So that's where we would ask you as a customer to send us some information on your process. Like, what is it? Have you done a DHA? By the way, we can help you do that. We can help coordinate that with a approved lab and everything. And once we have that, we have the equipment, we have the DHA results, we can help guide you to what's going to be required and safe.
Awesome. So the next question is for you, Matt. What are some OSHA regulations regarding combustible dust?
Okay, so now we're getting into the law, the legal requirements, and the NFPA stuff. So OSHA, which basically regulates your facility if you're in the United States, OSHA is the law essentially that says your facility must comply with these things. Specifically for combustible dust, OSHA has what's called a National Emphasis Program, or an NEP, specific to combustible dust. So if you just Google OSHA combustible dust NEP, you'll bring up their whole list of requirements. Now, within there, they kind of tell you what is required. You have to mitigate and the risk associated with combustible dust. They're not as prescriptive necessarily as the NFPA, which is referenced in the OSHA standard. NFPA is, you can think of it as like a list of guidelines. So industry experts over the years have developed the NFPA standards to serve as the benchmark for combustible dust protection. OSHA, as like the legal regulatory authority, points to the NFPA and says, if you have combustible dust and you follow the NFPA guidelines, you should be good. I will just add as one little caveat, really, NFPA, like I said, is not the law, it's the benchmark. So you can design your whole system to align with the NFPA standards and requirements. You still may have your fire marshal or your OSHA regulator come in and say, I want you to do this, this, or the other thing for whatever reasons. So that's why we always recommend that the customer bring in your regulators like with the plan, so that, because they're ultimately the one that's going to sign off, is your facility up to code or not. NFPA is there as the benchmark standard. Everything we recommend is going to be in compliance with NFPA, and the OSHA inspector is going to look at the NFPA and agree with it. But you also need to bring in that stakeholder, your regulator, let them know what you're going to do. So if they have questions, that we can address them up front.
Awesome. All right, and the next question is also for you, Matt. He's a customer that says, I am an architect and I'd like to understand what the proper steps are for confirming the appropriate building occupancy based on the DHA. How is determined if the hazard is great enough to require a hazardous building occupancy H2 designation?
Okay. So I looked at this question beforehand. I had to go do a little bit of digging to get a good answer. So there's two things they're talking about here. There's the building occupancy requirements and basically an architectural standard, IFC tables. And then you have the DHA. So there's a follow-on text where they're asking like, why isn't there a clear answer to, is it an H2 occupancy or not? It's because usually when you go get a DHA done, that third-party DHA firm is going to know the DHA, the NFPA stuff up, backwards and forwards. They're not necessarily going to be as familiar with the architectural standards for what's a hazardous building. So the answer that I was able to find, and I'm getting a little outside of my experience here, but basically the presence of combustible dust in the facility is not alone enough to trigger an H2 classification. It depends how that combustible dust is mitigated. So if you have combustible dust in your facility and you have added explosion vents, isolation, CO2, suppression, all the stuff that the NFP guidelines tell you to do, you should be able to avoid the H2 classification, because basically it says that you have combustible dust, but you've mitigated the risk. So typically it wouldn't be the DHA, auditor that defines that. It would be whoever is going to approve your occupancy designation. That may be like the architectural regulator. So that's getting a little bit outside of what we typically do. We focus on equipment and dust collection systems, how to mitigate the combustible dust risk. When you start getting a building code and stuff, there's other regulatory bodies out there, but my takeaway from what I could find online was basically if you're controlling and mitigating the combustible dust risk, to the extent that you can say that it's safe, then you should be able to avoid the H2 occupancy classification. So I hope that answers the question. If not, whoever submitted that, if they want to send an email or set up a follow-up, we can explore that further and get a good answer for them.
Sounds good. Thank you, Matt. Back to Joe. Is coal dust a hazard? Do you have any case study or experience with this kind of dust?
So coal dust can be a hazard. Again, we always recommend a full DHA done on the site to know for certain for that specific application. I've worked on several applications where they are using coal and there's coal dust and the DHA has come back with an ST1 class dust, ST1 KST values and all that stuff. So it just depends on what the DHA comes back with. But yes, it can be a hazard.
Yeah, so we would ask them that whoever answered or asked that question, send us some information on your process and we can help you figure it out.
And now back to Matt. The last question, thoughts relative to zinc dust specifically. Our facility galvanizes steel pipe and tubing products and uses both cartridge and backstyle dust collectors with cyclones. We have had sparks make their way into the units and cause fires, and since then installed spark arresters inline, as well as chemical fire suppression instead of water due to the reactive nature of zinc.
Yeah, so it sounds like so there's a combustible dust risk because they've had sparks ignite in the baghouse. So that's definitely a sign. We recommend they do the DHA to classify it. Maybe they've already done that and they've already installed spark arresters, which is a nice protection mechanism in chemical fire protection. That sounds reasonable. I would just maybe ask or to see a little bit more about their equipment setup. Do they also have explosion protection, isolation, etc.? Sounds like they're taking the right steps, but to be fully compliant with NFPA, they might need more protection. I don't know, Joe, what would your
Definitely.
approach be
Yeah.
there?
Yeah, that would, I agree with everything you said. We talk about like as far as that would be like what was listed would be more fire protection equipment. We would also recommend the explosion protection side as well, which includes the venting, the isolation between the vessels. So yeah, exactly.
Cool. Awesome. All right, that was the last question. And I looked at the chat box and nobody submitted any other, so I think we're good. So thank you guys very much for those answers. That was very clear. We appreciate your participation.
We appreciate the questions and the participation as well.
Yeah,
Awesome.
thank you for inviting me on. I appreciate it.
That's great. So thank you very much for attending this webinar. As I mentioned, after the webinar, we're going to send you the recording. So if there's some part that you would like to review, you will have that to watch again. And if you want to forward it to somebody else, that's also going to be great. So on behalf of all the team in backhouse.com, thank you so much for attending. And thank you, Joe, for attending as well in your participation. So if you have any question, that's our contact information, our number, our email. Feel free to give us a call, and that'll be it. Thank you so much.
Awesome. Thank you.
Bye-bye.